All right, so you've got a 3D printer or you're thinking about getting one. And you look at it and it's this awesome mix of, wow, I can make anything. And what on earth do all these settings mean? Well, you are in exactly the right place. Today we're going to crack the code. We're going to demystify the secret language of what's called FDM printing. I mean, that's the whole point, right? That's the magic of it. You have an idea in your head, and this machine, it can make it real. It's like a bridge from your imagination straight into something you can actually hold in your hand. It literally turns your digital dreams into reality. Ah, but here's the catch, isn't it? You fire up the software, and bam, you're hit with this wall of words. Infill, perimeters, retraction, support. What does it all mean? It honestly feels like you're trying to learn a whole new language. But hey, don't worry. By the end of this, you're going to be fluent. Okay, so let's jump right in. The absolute key to all of this is a piece of software called a slicer. Just think of it like this. It's the translator. It's the master chef. It takes your cool 3D model and turns it into a super detailed, step-by-step recipe that your printer can actually understand and follow. All right, first up, your print's blueprint. This is the architectural plan for your creation. Let's dig into the fundamentals. First thing in our toolkit, infill. Now, you might think your prints are solid plastic, right? Well, most of the time they're not. Infill is the internal skeleton, a sort of honeycomb or grid structure on the inside. Why? It's all about balance. A low infill, say 10–20%, gives you a fast, lightweight print, perfect for something that's just going to sit on a shelf. But if you need a part that can take some abuse, you crank that infill way up for maximum strength. Okay, so if infill is the skeleton, then wall thickness is the skin. Or maybe a better way to think of it is like armor. These are the solid outer layers of your print. They're also called perimeters or shells. It's pretty simple, really. The more walls you add, the tougher and more solid your part is going to be. And the third piece of our blueprint is layer height. I love this analogy. Think of your print as a giant stack of pancakes. If you use really thin pancakes, that's a low layer height, you're going to get a beautifully smooth, super detailed object. The downside? It takes forever. On the other hand, if you use thick, chunky pancakes, a high layer height, you'll print way faster, but you'll definitely see those lines stacked on top of each other. So, here's the bottom line. It's all a trade-off, a big balancing act. You can see it here. Want something fast, maybe just a quick prototype? Go with low infill and thin walls. Need a part that's super strong and durable? Crank up that infill and add more walls. And for layer height, it's always detail versus speed. The best part is, you are the one in control of that balance. Okay, next section, choosing your material. This is about picking the right ingredient for your project. Super important. When you're just starting out, you're probably going to be looking at these two. On one hand, you've got PLA+. Just think of this as your best friend. It's super easy to print with, it's reliable, and it's perfect for most things like prototypes or decorative models. Then you've got PETG. Think of PETG as PLA's tougher, more rugged cousin. It's stronger, handles heat better, and it's what you'll want for parts that actually need to, do something. Now, once you've got the hang of things, you can start playing with the fun stuff. For example, ASA. This stuff is an absolute beast. It's incredibly tough and weather-resistant. It just laughs in the face of sunlight. Perfect for something you're going to leave outside. And then there's something totally different. TPU. This stuff is flexible. It's rubbery. If you want to print your own phone case or maybe some squishy feet for a project, TPU is your go-to. So here's a little cheat sheet for you. You can see how it breaks down. PLA Plus is easy, PETG is strong, ASA is for the outdoors, and TPU is for squishy stuff. But, and this is a big but, always look at that main consideration column. Each one has its own little quirk, whether it's low heat resistance or being a little tricky to print. Keep that in mind before you click that print button. All right, our next topic is defying gravity, printing what seems totally impossible. So we've got our settings dialed in, we've picked our material. But remember, these printers build things from the bottom up, one layer at a time. So what happens when a piece of your model is just floating in midair? Yeah, seriously, how do you print in midair? It's a huge challenge, right? You can't just squirt out hot plastic into nothing and hope for the best. Gravity will win that fight every single time. Well, unless you give it a little help. The terms for this are overhangs and bridges. An overhang is pretty much what it sounds like. Any part of your model that juts out, like a chin on a statue or an outstretched arm. A bridge is when you have to print a flat line across a gap between 2 points. In both cases, the printer is trying to draw a line in the air, And that's where gravity can really mess up your day. So what's the solution? It's one simple word: supports. They're like temporary scaffolding for your print. Your slicer software is smart enough to figure out where your model needs help. You just check a box, and it will automatically build these thin, breakaway structures. They print right alongside your model, hold up all those tricky overhangs, and then when the print's finished, you just snap them off. It's honestly kind of brilliant. Okay, last section, the printer's first aid kit. Because let's be real, no matter how much you plan, sometimes prints fail. So this is all about turning that frustration into success. And we have to start with the most important, critical, #1 rule of 3D printing: bed adhesion. How well that very first layer sticks down. I'm not exaggerating when I say this is everything. That first layer is the foundation for the whole skyscraper you're about to build. If it doesn't stick perfectly, the whole thing is coming down. Game over. The good news is there's a checklist for this. First, make sure your build plate is perfectly level. We call this tramming the bed. Second, clean it. A little isopropyl alcohol goes a long way. Fingerprints and dust are your mortal enemy here. Make sure you've got the right bed temperature set for your material, and if all else fails, use a brim or a raft in your slicer. A brim just adds a single wide layer around your part space, giving it way more to hold on to. So what happens when you have bad bed adhesion? You get this ugly problem called warping. You've probably seen it. It's when the corners of your prints start to lift up and curl like a potato chip. What's happening is that as the plastic cools, it shrinks just a little bit. And that shrinking force is literally strong enough to pull the corners of your print right off the bed. Another super common thing you'll see is stringing. Ugh, the worst. It's when you get these thin, wispy spider webs of plastic between different parts of your model. All it is really is a tiny bit of melted plastic that oozes out of the nozzle while it's traveling from one point to another. But don't worry, we can totally fix this in the slicer settings. Your #1 weapon against stringing is called retraction. This setting basically tells the printer to suck the filament back up into the nozzle just a tiny bit before it moves. It's like stopping the drip. You can also try dropping your print temperature just a few degrees or making the nozzle travel faster. And hey, pro tip, make sure your filament is dry. Wet filament loves to string. And that's it. That's the core toolkit: infill, walls, layer height, filaments, supports, and a first aid kit for troubleshooting. You get these things and you're not just a user anymore. You are a creator. You're someone who understands the language of your machine and knows how to make it do what you want it to do. So there you have it. Your toolkit is packed. You've got the blueprints, you know the materials, you know how to fight gravity, and you know how to fix things when they go wrong. So really, there's only one question left, and it's the most important one. Now that you can make pretty much anything, what are you going to create first?